So let's do one more example. And this one is tricky because of the way it's worded. So which value for the constant c makes z equals 2 an extraneous solution in the following equation? And we're given this equation that has two variables in it. It has z and it has c. Now you might be tempted to just plug in z equals 2. And if you did that, what you would end up with is a value for c that actually gives you a real solution to this. So just plugging this in and solving it won't give us our extraneous solution. Because remember, the extraneous solution comes when we square each side of the equation. The extraneous solution essentially comes from solving the equation where you have the opposite of the square root of 7 minus 3z. And to get that extraneous solution, like I mentioned, we just need to square each side and solve that equation. So let me just rewrite it. We have 7 minus 3z underneath the square root is equal to 3 plus cz. And at this point, we'll square everything. And once we square everything, then we'll end up with our extraneous solution in that resulting equation. So square and square root cancel, we get 7 minus 3z. And here we'll just rewrite it twice so that we can multiply it out. But since we've already squared it, and this equation is going to have two solutions where one of them is extraneous, at this point we can plug in our z value of 2. But first I'm going to multiply everything out and then I'll plug it in. So on this side we have the 3 distributing, so you get 9 plus 3 times cz. And then the cz distributes, we get plus 3 times cz again, and cz and times by cz would give us c squared times z squared. And like I mentioned, now we can just plug in our z value. We have that z is 2. And once we do that, you'll see we end up with a quadratic equation, which will give us two solutions where one of them will actually make sense and the other one will be extraneous. So from there, we have that 7 minus 3 times 2 is equal to 9 plus 3 times c times 2. And we're going to have that again, 3 times c times 2 plus c squared times 2 squared. So c squared times 2 squared. And let's just simplify everything. So we'll need a little bit more room here. And we get 7 minus 6 is equal to 9 plus 6c plus 6c, which we can combine these together since they're like terms. And we have 4 times c squared. So 7 minus 6, that's just 1. We get 9 plus 12c plus 4c squared. And let's subtract 1. This is a quadratic, so we can solve it. So we get that 0 is equal to 8 plus 12c plus 4c squared. And notice everything is divisible by 4. So just to make our work simpler, let's divide both sides of the equation by 4. And we get that 0 is 2 plus 3c plus c squared. And usually you want to write your quadratics in standard form so that they're easier to factor or use the quadratic equation. And this one is factorable. So let's write it as our product of two binomials, where we have two terms in each of these. And we know that the first terms have to be c and c, since that's the only way to get 1c squared. And likewise, we know that this term and this term, they have to multiply to 2, and they also have to add to 3. So we can look at the possible numbers that can multiply to 2. So 2 and 1, or minus 2 and minus 1. And which of these adds to 3? Well, that would be 2 and 1. So you get plus 2 and plus 1 here. And of course, our equation is equal to 0, and we have a product. So from here, we can use our zero product property and recognize that when c is negative 2, it will solve this equation here. And when c is negative 1, it will solve this equation here. Since remember, we're just trying to make each of these equations equal to 0, since 0 times anything is 0. So we got our two solutions for c, and now we just need to figure out which one of these is extraneous. So let's go back up to our problem. And we know that when c is -2 or -1, it'll solve this equation when z is equal to 2. And we'll plug them back in, and we can plug 2 in as well and see what actually makes sense. So now we will check our work. And let's just start with c is -1. So when we plug that in, and remember we're also plugging in z is equal to 2 here from our original equation. So we get the square root of 7 minus 3 times 2, which is 6. Is equal to 3 plus cz, so minus 1 times 2. And on the left-hand side, we get the square root of 1. And on the right, we get 3 minus 2. And so the square root of 1 is just equal to 1. And on the right, we get 1. So when c is -1, this is actually a solution to this when z is equal to 2. So this one's okay. That's not extraneous. But at this point, we just need to check that c is equal to -2. And it should be our extraneous solution since it's the only one left out of the two. So we will check when c is -2, and of course z is still equal to 2. And plugging that in, we get the square root of 7 minus 6 again, so I'll just write that as square root of 1. And now we get 3 plus c, which is now -2, times by z of 2. And we get that 1 is equal to 3 minus 4, but 3 minus 4 we know is -1. And 1 is not equal to -1. So when c is equal to -2, we end up with a solution that doesn't make sense. And so -2 is our extraneous solution. It's the solution for when we're looking at the opposite of the square root of 7 minus 3z equals this right-hand side.